Welcome to Project Risk Management. As we discussed earlier, the essence of all management is plan, do, check, and act. So whatever we want to do, we plan first, then we implement the plan, and once in a while we check to see whether things are happening as per the plan, and if there is a variance, we take action. Risk management is no exception to this PDCA cycle. First of all, we have to plan for risk management, establish the risk management objectives, and create a plan because we need a team, we need the resources, we need to have a schedule. So that must be established first. Then during the execution phase of the project, we get into risk identification, which is a continuous process. We do risk identification at the beginning of the project as well as throughout the project because new risks will emerge and existing risks can become insignificant. So it has to be, this is a continuous process. Then the next one is qualitative risk analysis, followed by quantitative risk analysis, and there are other risk assessment challenges. We'll discuss about them. Then once the risks are identified, then develop strategic risk responses and analyze contingency, and then act, that is risk monitoring and communication, update the project plans, and develop and maintain methods and tools for risk management. So this is the sequence. Now, we start with plan risk management. Risk, there are two types of risks. There are positive risk as well as negative risk. A positive risk is something that is good. If we exploit it, that is good for the project. For example, you are launching a new website. A lot of people have registered, a lot of traffic to the website. And if that is managed well, that becomes an advantage. Or you're launching an online course, suddenly there is heavy demand. So if you can manage it well, then it will end up in a lot of benefits. So is the case with you're publishing a book and you are expecting 100,000 copies to be sold in the first 6 months, but then you realize that there is demand for 500,000 copies. So which is very positive risk. But if you cannot leverage it, that opportunity is lost. So risk need not be always negative. There are positive risk as well. And then we have the negative risk. There is a possibility of an earthquake happening. That is a negative risk. There is a possibility of a tsunami happening. That is a negative risk. There is a possibility of schedule overrun. That is a negative risk. There are basically a project comprises of individual risk and which leads to overall project risk. So we have risk 1, risk 2, risk 3, and the compounded effect will have an impact on the overall project risk. Then event-based and non-event-based risks. An event-based risk, like a supplier went bankrupt, that event happens, or block in the shipping network, or political unrest, pandemic. These are all examples of event-based risk. And then there are non-event-based risks. These things happens gradually. It is a variability risk, like productivity below target, productivity above target. And then we have ambiguity risk, that is unable to freeze the requirements and viability of the business case of the project are ambiguity risks. So basically two types, event-based risk and non-event based risk. Enhancing project resilience. Example, right level of schedule and cost contingency for emergent risk. So we make the projects resilient to the risk by adding contingencies to the durations as well as to the effort and cost. So you right level of schedule and cost contingency for emergent risk and flexible project processes and empowered project teams who can make decisions and frequent reviews and clear inputs from stakeholders. In one of our earlier lessons, we spoke about the triple constraints of the project. That means a project is successful if it is completed within the agreed upon time, uh, and it gets over within the cost, and it meets the scope, time, cost, and scope. Now, we can always define a decision criteria, like we call it as a flexibility matrix. So here we can decide at the beginning of the project itself, we should decide or we should get concurrence, like highly flexible, moderately flexible, and least flexible. So if this agreement is obtained between the project manager and the other high power, high interest stakeholders, then time, is it highly flexible or moderately flexible or least flexible? For some projects, the time can be very important. So time can become least flexible. It will vary from project to project. Then cost, maybe in this case, cost can be uh, sometimes highly flexible, and scope is moderately flexible. So if the moment we have concurrence on this flexibility matrix, this has a direct impact on our risk management decisions as well. So this must be done upfront at the time of project chartering or at the time of project planning itself. Uh, Integrated risk management, because risks have this bottom-up effect. Project level risk will impact will have a major impact on program level risk, and these two risks will have an impact at the portfolio level. Managing the bottom-up and top-down impacts in an integrated manner, that is critical to success of the project and risk management. Then the contents of a risk management plan, it should have a risk strategy. How are we going to deal with it? The methodology, roles and responsibilities, funding for risk management, timing, then risk categories. There is no standard categorization. Project to project, it can vary. Then we have the risk breakdown structure, stakeholder appetite for the risk. Some stakeholders can be risk averse, whereas some stakeholders can be they are okay in taking risk. Then definitions of risk probabilities and impacts. We need to have scales for it. Some organizations, it can be from 0.1 to 1, or it can be 1 to 5, and the definitions for that. What is 1, what is 2, what is 3, and yeah, the criteria for that. Then probability and impact matrix, reporting formats for risk and tracking mechanism. All these things can be part of your risk management plan. So as discussed earlier, whatever that consumes time and cost must be part of the must be scheduled, must be part of the plan, must be part of the work breakdown structure. So risk management will definitely consume time, effort, and cost. So this must be factored into the plans. This is a risk breakdown structure. So we have the work breakdown, we have the product breakdown structure, we have the work breakdown structure. From the work breakdown structure, we can actually direct out the risk breakdown structure. Or this is another way of grouping by affinities. We have the category 1, category 2, category 3, and the risk falling into category 1, schedule-related risk, let's say, that can be here. Cost-related risk, if that is the category 2, that can be grouped here. And scope-related risk, if that is the category 3, that can be grouped here. There can be further things like manpower-related risk, supplier-related risk, contract-related risk. So it's up to the project to decide. So this is an example of risk breakdown structure. Now, the next process is identifying the risk. The tools and techniques, brainstorming, checklists, interviews, root cause analysis, assumption and constraint analysis, SWOT analysis, that is strengths, weaknesses, opportunities, and threats. Then document analysis. By analyzing documents, we can always come out with risk. Sometimes there is a saying like anything for which if you're unable to write a test case, that is a sorry, that is a possible risk. Facilitation skills, prompt lists. These are, or we can use all these tools or some of the tools for identifying the risk, and the captured risks are captured into a risk register or risk report. And then we have other frameworks to analyze risk. The first one is the PESTLE. PESTLE, P stands for political risk, economical risk, social risk, technological risk, legal risk, environmental risk. So this is one way to really look at the external risk to the project. Then we have the VUCA, that is volatility, requirements volatility, uncertainty, complexity, and ambiguity. So this is slightly inward focused, whereas this is externally focused. This will help us to identify the risk external to the project, whereas the VUCA will help us to identify the risk internal to the project. Then meetings is definitely another tool for identifying the risks. Then comes qualitative risk analysis. It is very simple. You identify the risk. We have the risk register for it. Now, for every risk we cannot manage or need not manage, so we rank the risk based on two parameters. One is the probability of the risk and the impact of the risk on the project. So tight schedule, we have given a high probability of 5. That means it is already existing. It is definitely bound to happen. And if the tight schedule happens, the impact is 3. So probability into impact, that is the risk rating, that is 15 here. And cost escalation, the probability is 3, impact is 3. So in this instance, it is 9. The cumulative score is 9. So likewise, poor productivity, you get a score of 12. Poor quality of the cement supplied, probability is high, but the impact is low. We can always get a replacement for it. Manpower not available on time, probability is 3, impact is high. So cumulative P into I is 12. Likewise, we get a score for this risk, and we can have a norm like anything 10 or above, we will manage. Others can be under observation kind of norm if we have in the project. So in that case, tight schedule, it has to be managed because the P into I is 15. Poor productivity will manage because the P into I is 12, and manpower not available on time. Then P into I is 12, that we'll manage. Adverse climatic conditions we have to manage. Scope changes very high, so it has to be managed. Now, this is the basic qualitative analysis, but if you want to really go aggressive on risk management, another parameter to be considered can be the urgency. This risk is going to happen immediately, like requirements related risk. Oh, this is going to happen immediately in the first phase itself. So this must be managed immediately. Whereas testing related risk, oh, that need not be managed immediately because that is going to happen at a later date. So it is not very urgent. So some teams, they not only give weightages for probabilities and impact, but they give weightages for urgency, and another thing is difficulty to detect. An unknown risk happening that is very difficult to detect. Maybe an earthquake going to happen, that is very difficult to detect. So for such risk, we must give more weightage. See, the ordinary qualitative analysis, we stop with P into I, but I feel it makes more sense if we add parameters like urgency and difficulty in detection. Then quantitative risk analysis. So whatever we prioritized in the qualitative risk analysis, that undergoes quantitative risk analysis. Generally, in project teams, we stop with qualitative risk analysis, but maybe high intensity projects like maybe a Chandrayaan kind of projects or credit risk analysis. We use sometimes simulation techniques. The most popular technique is Monte Carlo analysis. And we have other sensitivity analysis tools as well. Now, Monte Carlo analysis. Now here, let us say we have a set of risks. So if you want to reduce the cumulative impact, either I should make the probability of risk 0, or I should make the impact of the risk 0. In that case, the probability into impact can become 0. P into I will become 0 by making either probability 0 or impact 0. But making the P into I 0 can be very expensive and which may not be required. For example, a waterproof watch is more expensive than water-resistant watch. So we need only water-resistant watches. We don't need waterproof watches. or water resistant mobile phone is okay. We don't need waterproof mobile phones. So we will not try to make probability zero, but we want to know the ideal values for this, because making this zero can be an expensive affair. An earthquake-resistant building which can withstand, let us say, an earthquake up to 7 on the Richter scale is more viable than an earthquake-proof building, because the cost of construction can be very, very high. So by running the Monte Carlo analysis, it will give us the optimal values for these probabilities and impacts. These are automated tools based on simulation techniques. So you give activities and their probabilities and impacts as an input, and the output is the ideal values for probabilities and impact after considering the correlation between the risks and stuff like that. Now let us, at this stage, we have planned for risk management. We have identified the risks. And on the risk identified, we performed qualitative analysis. That is just P into I. Then quantitative analysis, that is Monte Carlo analysis. Now we know which risks need to be addressed immediately. So we plan risk responses for these risks identified or qualified. Action planning to minimize probability and or impact of individual project risks, thus reducing the overall project risk. Strategies for threats, strategies for opportunities, contingent response strategies. That is, building an earthquake resistant building is a risk response action. But the actions we take when an earthquake is really happening, that is a contingency action or a contingent response strategies. That is why we have this mock fire drills and stuff like that. So people should know what they are supposed to do if there is a fire breakout. Then we need to have strategies for overall project risk. Individual risks we can, but then what about the overall project risk? So here we need to have the management reserves and stuff like that to manage this type of risk. Then we have alternatives analysis and cost benefit analysis and multi-criteria decision analysis. So maybe we manage risk by substituting the materials involved. If a risk is going to happen because of poor raw material, poor supplies, we need to do alternatives analysis and go after those alternatives. And for that, we may do cost benefit analysis and a multi-criteria decision analysis for the same risk. Maybe we can manage in different ways. And each way will have an associated cost, timing, efficiency, etc. So we can evaluate these multiple strategies based on multiple criteria and then pick up the best. So that is the application of multi-criteria decision analysis in risk management. Risk response strategies, threats, we can escalate to the next level, we can avoid them, we can transfer that risk to somebody else through an insurance. Or we can take actions to mitigate the risk by either reducing the probability or the impact, or by reducing both the probabilities and impact. And sometimes we accept the risk, saying that I'm willing to take it. So if it is happening, let it happen, kind of thing. Escalate, you just escalate. Avoid. Uh, uh, now you're building a new building in a low-lying area, which has the threat from climate changes. So just avoid it. You don't construct it there. You move to some other area which will not be impacted by climate change. Then transfer is by taking an insurance coverage. The risk will still happen, but you transfer it to another agency. So these are the common strategies for addressing the negative risks or the threats. And here we have the strategies for addressing the opportunities or the positive risk. Again, escalation. Instead of avoiding it, you try to exploit it. Maybe you share. Now, let's say you're doing a joint development of a product, and suddenly the profitability is too high. Then you share the benefits with the other stakeholders as well. And you take actions to enhance the opportunities further, and you accept them sometimes. That means you don't take any action. You just say, I'm willing to take it, even for positive risk. Then implement risk responses. It is implementation of risk responses within projects. I consider them as mini projects within the same large project, because every implementation of a risk response or the risk preventive action that involves planning, then you have to do it. Then you have to check for the effectiveness of those actions. And if it is not effective, you have to take action. So all risk implementation activities within projects, they must be considered as mini projects within the main project. Then monitor risk. This is important because for effective risk management, monitoring and controlling the effectiveness of the risk response actions and the contingency actions. Tools and techniques, technical performance analysis, reserve analysis, because we have to see the management reserves available. Not only the management, the contingency risk also. Then audits must be performed to monitor and control risk, and meetings also will help us to do it. A qualitative risk analysis, we already discussed about it. By monitoring or reassessing the probabilities and impacts periodically, that will help us, because this P into I rating will change during the execution of the project and based on the effectiveness of the risk response actions. Now, another common thing is the risk rating matrix or the risk heat map. Now, here if you see, here we have a band of risk whose probabilities are very high. Probabilities are very high, and their impact is also, the impact is very high, and the probabilities are also pretty high. So and urgency is also very high. So these things, this red color risk that is happening, that must be given top priority. Then you have this yellow band of risk. That is okay. That must be under observation. And then we have this green color here. Probability is low, and the impact also can be low. So for the time being, we can ignore them. So there are tools available where which will help you to monitor the risk heat map on a daily basis. And if you click on each cell here, you'll be able to do drill down analysis, which will pinpoint to the exact area in the project where this risk is happening, and the details about the risk, the corrective actions performed, who is the owner for this corrective actions. So you can always do a drill down analysis from a risk heat map. There are tools available, the digital PMO tools available, which will help you to do that. Then we can always draw a risk burn down chart. This can be done for individual risk as well as for cumulative P into I. For individual risk, we can put the probability into impact on the y-axis. And as the project progresses, we have to reassess them. So if it is on a diminishing trend, then your corrective and preventive actions are effective. This can be done for the overall project level. So because if you put the cumulative P into I on the y-axis and continuously monitor on timeline, we'll get a burn down chart. So that is, it can be used for individual risk as well as for cumulative risk. Risk burn down chart is very effective tool. Thank you very much. I hope this video gave you an awareness about risk management. Thank you.